All right.
Yes. So like every word you put in.
All right, go ahead and turn your quiz in. Make sure your name's on there. Thank you. Alrighty. I think I got everybody's. So I got everybody's. I got all of them.
I was, as the kids say, lacking.
Yes.
You got everybody?
Oh, wait, no. I literally just put yes.
Hey, you take my mission back.
It's okay. Yes. What's the?
At some point, I mean, sorry, Dr. Cook.
I once had I had a student for a few years ago. His name was Landon. He used to call me Dr. Professor Cook to be doubly respectful.
Wait, what's his last name? What did we call
I don't remember.
Dr. Professor.
Was he what?
Cook,
Was he a ginger?
Yeah.
What's that mean? Just kidding.
He got you. You thought you thought he didn't know.
Sorry, I'm a horrible person. I don't think he was. I think. What did he look like? I don't remember. I don't know, it's just. These white people all look the same. I don't know. I mean. But. Okay, so I think I have everybody's quiz. Hopefully. Thank you. Let's get started here. Yeah.
How would you recommend we prepare for the final exam?
Ooh, I think the best way to prepare for the final exam is to understand the material.
That's great. What's the best way to do that?
Do all the homework.
Yes. But also, if that doesn't work, what else?
Do all the quizzes.
Well, we have to do all the quizzes.
But do you understand the quiz? So like if you,
I look up a lot of tutorial videos on YouTube,
yeah,
and sometimes they help.
yeah. I know I do. You know, I will post a solution to the quizzes so you can look at those, and if those don't make sense, you can ask me questions about them in here or whatever. Yeah. See here. Of course, you also have you get a sheet of notes for the final, right? I think I said you can have 3 pages of notes for the final, right? 3 pages front and back. Yeah.
Okay.
So, you know, I would go back and.
Are we going to get one class period to take the final?
It's like it's like a 2-hour final. 2 hours.
On the 5th, so 3:30 to 5:30.
Okay.
Yeah. All right. Oh, thank you. You guys have any questions about? So, I mean, I would say. Thank you. So, it's important that you try to get as many points as you can from the homework, obviously, because you have, you know, complete, more or less, you guys gotta stop talking. Otherwise, I'll have to get my whistle. You want me to get my whistle? Oh man, that's right, I forgot.
What if we don't talk about
So, what I was gonna say is, you know, a lot of you, I saw, you know, these are pretty good scores on the homework, and by and large, you guys haven't missed too much of it. That's good, but try to miss none of it, right? Because then those are points that you can take with you, and you don't lose them, and that might help you out in the big scheme of things here, right? Because there is one more mission, right? Mission 3 to turn in. Now, if for some reason you haven't turned in the missions, right? Please come talk to me after class, all right? So, but the final exam is comprehensive, so it's important to go back to, like, test 1 and test 2 and try to figure out what went wrong and try to fix it, right? So let's see here. Let me start working some more problems for us today. Here's one. This is section 4.4, number 92. And here we're up against the natural log of the quotient of a cubed divided by b squared. And we're supposed to, and they say let u equal to the natural log of a and v equal to the natural log of b. You're supposed to express the given quantity in terms of u and v. So how do we do this? And then there's another one with the same instructions, but the next one is like the natural log of the cube root of a times b to the fourth. So let's do both of these. They're the same instructions. This is like number 94. All right, so what we do is we go, this is the natural log of a cubed minus the natural log of b squared, right? One of the properties of the log is that the log of a quotient is the difference of the numerator and the log of the denominator, all right? And then what? Well, the 3 and the 2, they pull out by the power property here. So this is going to be equal to 3 times the natural log of a minus 2 times the natural log of b. All right, so let me write it over here. We'll be using natural log of like a times b is natural log of a plus natural log of b. And the natural log of, say, a to a power p is p times the natural log of a. And the natural log of a over b is the natural log of a minus the natural log of b. So we want to keep these in mind, all right? Okay, so so what's the answer here? Well, we're supposed to write our answer in terms of u and v, right? So how's that go? This is equal to what? See this right here? That's my quote-unquote u. This right here is v. So the answer is 3u minus 2v. There you go. It's kind of a interesting format for the questions, the way the book does it here. Now let's see here. This one, I have the natural log of the cube root of a plus the natural log of b to the power 4. All right? What is the cube root of a equal to? What does that mean in terms of the exponential notation? So the cube root of a is equal to a to the 1/3 power. So I'm really looking at the natural log of a to the 1/3 power. And now this one here, I can pull the 4 out, right? So I got plus 4 times the natural log of b. So the 1/3 power pulls out just the same. And I get 1/3 natural log of a plus 4 natural log of b. And so remember, log a is u and log b is v for this problem. So the answer is 1/3 u plus 4 times v for this problem. So this is this calculation we're doing, I would say this is expanding the log, right? What we're doing is we're expanding the logarithm in each one of these. But it's got the extra wrinkle of writing the answer in terms of u and v. So that's kind of fun. Let's see here. Let's look at number 96 from this section. Here we're given a formula. We're given that f of x is equal to 3 to the power x. And we're supposed to calculate a couple different things. A, we're supposed to calculate f times, not f, but f of rather log base 3 of 2. For part B, we're supposed to calculate f of the log base 3 of the natural log of 3. And then part C, we're supposed to calculate f of log base 3 of 2 times the natural log of 3. All right. Let's see here. So let's do these. Now A is pretty easy, right? What is f of log base 3 of 2 equal to? What's that mean? This is function notation, right? That means you plug x equals to log base 3 of 2 into the formula. So we have 3 to the log base 3 of 2. But remember that the log base 3 and the exponential base 3, these are inverse functions. Yeah? So the answer here is just 2 for part A. How does part B go here? So we've got 3 to the log base 3 of the natural log of 3. So many 3's. So this time, the answer is just, remember again, they're inverse functions, so this just spits back out again. Answer here, natural log of 3, which is a number, whatever it is. And then C, again, since 3 and log base 3 are inverse functions, again, this will become simply that, which is 2 natural log of 3. Now you could also write this the natural log of 3 squared. So you could say the answer here is the natural log of 9 if you wanted. Whatever. I don't know. I think problem 96 is kind of dumb. I don't think it's particularly interesting, honestly, guys. Let me move on here. So section 4.5 is, so section 4.4, basically the idea of section 4.4 is just to get familiarize yourself with the exponential and the log and how they work and how they interrelate, okay? And how to calculate values of them. Section 4.5 is more where the rubber hits the road. Here we're solving equations involving exponentials. So we did some of these last time, all right? But I want to do some more today. And the ones I'm going to do today are going to be a little bit trickier, by and large. So let's start out with something that's just marginally trickier, like this. Number 20, section 4.5. Number 27. I'd say this is just a little bit trickier than what we did last time. 0.05 times parentheses 1.15 to the power x is equal to 5. So how do you think we should deal with a problem like this? Multiply the what? Okay, well I can't do that. I can't just multiply that into that because there's an x there that keeps me from doing it. But I like your general idea, which is to do something about the 0.05, right?
Divide that 0.05.
Oh, okay, yeah. So 1.15 to the x is equal to 5 divided by 0.05. What's that work out to? I think it's 100, right? You want to check me on that? If My calculator says it. That must be true then, right? My calculator says 100. There's proof.
Yeah, you're right.
Just kidding. So, all right. Well, this is not a particularly 1.15 is not a base I have any kind of intuition for. So when I come up against something like this, I just natural log the thing. So the natural log of 1.15 to the power x is equal to the natural log of 100. But the power properties for the log gives me x times the natural log of 1.15 equals to the natural log of 100, which then gives me x is equal to the natural log of 100 divided by the natural log of 1.15. And there you go.
So you can't express it.
No, there's nothing nice to do there except with a calculator. Yeah. Let's see here. I guess I'll keep going here. Example. I won't refer to example. I'll refer to problem number today. How about that? Change of pace. Section 4.5. Now this one's, if I remember, this one's actually quite a bit different. Number 37. This one's going to require a really different technique if I remember right. So 2e to the 2x, all right, plus e to the x equals to 6. This is a different kind of problem than the ones we've solved so far. This is not the same pattern as we've dealt with thus far. See, I can't isolate the e. Well, let me show you what happens if I try to use natural log, right? Let me just try to solve this with the methods we've had already. If I just isolate e to the x, what do I get? 6 minus 2 e to the 2x, right? If I take the natural log of both sides, what do I get? I mean, I get x is equal to this, right? But now I've got x is equal to, and now the natural log of 6 minus 2 times e to the 2x. I mean, the x is getting more intertwangled with the natural log on the right-hand side, even though I've freed it on the left-hand side. And no matter how I play this game, I can't isolate x, all right? I'm just telling you, we could try this for like 10 minutes. It would get nowhere. Something different has to be done. Do you guys know what it is? What? There's a trick, if you will. We need a new thought, yeah? Let me write something suggestive. E to the 2x is actually e to the x squared. And I can move the 6 to the other side. Look at this. What is it now? Does this remind you of anything? Let me make one more step. What if I let y equal to e to the x? Then what am I looking at? I'm looking at 2y squared plus y minus 6 equals to 0. What is that? Well, that's a quadratic equation in y, right? So we know what to do with that. What do we do? I mean, you got choices, right? You can use the quadratic formula. You can complete the square. This is a book problem. So in my heart, I believe I can factor it. I want to get 6. So I either need a 1 and a 6 or a 3 and a 2. I think 3 and 2 are the way to go. I'm going to say minus 3 plus 2 here. I think that'll do it because when I multiply, I get 2 times 2, which is 4. I get 3 times 1, which is 3, but there's a minus. So 4 minus 3 is 1, right? 4 minus 3 is that 1. Minus 3 times 2 is the minus 6. We got it. All right, this actually factors like that. And then what do we get? We either get 2y minus 3 equals to 0, or y plus 2 equals to 0, right? In other words, we either get y is equal to 3 halves, or y is equal to minus 2. Now, is that the answer? Well, it's not the answer yet, because what do we need to do? We're looking for x, not y, right? We made a substitution, now we need to unsubstitute. So what we're looking at, we got e to the x equals to 3 halves. We've got e to the x equals to minus 2. Now how do we solve those? We solve those like we solved things last class, right? Take the natural log of both sides. What do I get? This gives me x is equal to the natural log of 3 halves. And this gives me x is equal to the natural log of minus 2. So you guys put those in your calculator. Tell me what you get. What did we get? I mean, this is some decimal number. What did you guys get? Tell me.
0.405465108.
That's good. So there you go. That's one. And how about this one? You guys must be punching it in wrong. How long did it take to find the answer? Come on. I'm joking, of course. This one does not exist. The natural log of a negative number does not exist. So this is not a solution, it's extraneous. Let me explain this graphically to you. What does e to the x look like? It looks like this. Here's y equals e to the x, right? What does y equals minus 2 look like? It's the horizontal line, right? It's like down here. Never the twain shall meet, right? I mean, these two have no point of intersection. There is no solution. In contrast, y equals 3 halves. Where does that intersect y equals e to the x? Well, that one, if you were to graph it, intersects about right there, which you guys just told me is about 0.405-ish. That's where that intersects, that x. So yeah, we got to check. You got to be wary. If you find yourself taking the natural log of a negative number, you got to throw that one out. All right, this can happen. Let's see here. Let me go on, work a different problem. Section 4.5, number, let's see here, number 40. I'll work that one for you guys. Here we have 3 to the 2x minus 12 times 3 to the x, all right, equals to minus 35. Interesting. What do you guys think? How should we solve this one? It looks like it's kind of the same kind of problem as we just had, right? This is another one of these ones we're going to have to think about as a quadratic. See, the 3 to the 2x we look at as 3 to the x quantity squared. And then we've got minus 12 times 3 to the x plus 35 equals to 0. Let y equals 3 to the x. This gives us y squared minus 12y plus 35 equals to 0. Since this is a book problem, I believe it will factor nicely. Am I right? What's 35? 1 times 35 or 7 and 5? I got a 12. Oh, what did you say? Mi-
-7 and then -5.
-7, -5. I believe we have a winner because -7 minus 5 is -12. -7 times -5 is 35, so factored. And so y equals what?
7.
Yeah, y equals 7, or y equals to 5, but we don't want y, we want x. So we're up against, what we're up against? We're up against 3 to the x equals to 7, or 3 to the x is equal to 5. Now we can solve these a few different ways. The easiest way to solve these is to use log base 3. So if we take log base 3 of these equations, what do we get? So log base 3 of 3 to the x equals to log base 3 of 7. Log base 3 of 3 to the x equals to log base 3 of 5. Therefore, x equals log base 3 of 7, or yeah, x equals to log base 3 of 5. So this time, we got two solutions. So there doesn't have to just be one solution. There could be two. You could have one where there's just no solutions at all, right? Here, let me show you one with no solutions. I guess this is my first example. Example 1. Check this out. Minus 3 to the 2x minus 7 times 3 to the x equals to 4. Listen, guys, I don't need to do anything. I don't need to make a substitution. I don't need to go through everything I just went through. This one, I can just look at it and tell you there are no solutions. How do I know this?
Because there's negatives.
Right, I can tell you there's no solutions because this side is manifestly negative, all right? It's clearly negative, yes?
So would it be the same, like, imagine if they were like positive or whatever, and then the 4 was negative, would it still be the same?
Yeah, if you can see unequivocally that you have an equation with positive on one side and negative on the other and there's no way to remedy it, then there's no solution. But you have to be careful because you can deceive yourself into thinking something's positive when it could be negative. Like, for example, x squared plus 4x equals to minus 3. You might say, oh, well, this is positive and that's negative. There can't be a solution. But the thing is, this could be negative if this is negative. This could be negative if you put a negative number in, right? So it's not clear at the outset whether or not this actually has no solutions. Like, and it may or may not. I don't know. Oh, duh, that factors. What am I doing? I'm a dummy. X plus 1 times x plus 3, right? Duh. I didn't really need to complete the square, did I?
What was it wondering?
Well, you know, when you have a hammer, everything looks like a nail, is what they say. Let's see here. So anyway. Yeah,
Is the hammer the ability to complete the square?
pretty much.
An analogy?
That's, for me, the completed square is a hammer. It crushes everything. Anyway, enough of this one. Let's go on. So the answer to my example 1 is this is obviously positive, right? So therefore, no solution. Now, if I did go through the process that we did in the previous 2 problems, what would happen is we'd get a quadratic equation which has complex solutions. That's what would have happened. or they either be complex or they both be negative. And in either case, we don't have a way to solve for the solve the exponential. Alrighty, let's see here. Let me work some more problems. So the ones we're about to get into have a different flavor. They have a different starting point. So here we go. Number 41. So I'll start out with some relatively easy ones, like this one. 5 times the natural log of x is equal to 10. So now we're working on solving equations involving logarithms directly, all right? So we'll be up against these problems for a little while. So what do you guys think I should do here? 5 times the natural log of x equals to 10. I should divide by 5, right? We all agree? Divide by 5. That gives us natural log of x is equal to 10 over 5, which is otherwise known as 2. Natural log of x equals to 2. How do I solve this? The key identity, right, is that the exponential of the natural log of stuff is equal to stuff. So if I have if I have a log, what I want to do is just exponentiate both sides of the equation. E to the log of 2 is equal to e to the 2. But e to the natural log of x is just x. So the answer is x is equal to e squared. There you go. That's how you do it. I know, it does. It feels silly. Let me just play 7.5 over 45 log of 2 is x equal to 0.5. is what?